So tonight we're doing the next topic, okay? So last Thursday, the first topic of this unit was going from calculate, okay? And that's getting ready to plot a sun line, a star, okay, planet, okay, a line of position. Tonight we're going to do LAN, okay? So it's pre-computing the time of LAN and reducing and getting your latitude at LAN. That's going to be setting you up to combine like a morning sun line and advance it to an LAN to get a running fix, okay? And then the next class will actually do plotting, okay? And it'll involve plotting, it'll involve combining everything, okay? So taking the LAN, taking the HC to ZN, okay, taking a up to LAN for running fix, and then reducing stars. And it's all about position fixing, okay? And mixed in there as well was the pre-computing the time of sunrise or whatever. We're going to be pre-computing the time of LAN. We'll be following the same method. So I'm going to go over the wicked easy always add, how to do it in the east, which is wicked easy always add in the west. Kind of a pain in the ass in the east, but I'm going to show you how to do that. And we're also going to, I'll show you how to do it off of your central meridian. So we're going to cover both of those things tonight. So if you're a little bit like, oh God, I don't quite remember that, I'm going to show you both methods again tonight, okay? All right. So local apparent noon, it's really meridian passage. Local apparent noon is when the sun is on your meridian. Meridian passage is when, like here's the earth, here's the equator. Let's say this is your longitude, bodies rise in the east, okay? So as the morning progresses, they're getting closer and closer to your longitude. And at some point, they're gonna be on your longitude. That's meridian passage, okay? So if you were in the southern hemisphere, they would, they'd be to the north of you. If you're in the northern hemisphere, anyway, at meridian passage, your meridian and their meridian are the same meridian, and the celestial triangle collapses. Okay. Anyway, so that's so what it does is it's a lot easier to reduce it. Okay. Instead of going through some long celestial reduction where you need LHA and declination and latitude, okay, you can do a much simpler calculation. And I'm going to show you right where the formulas are in Bowditch. Okay? You don't even have to derive them. Okay. So, in Bowditch 2, there's a whole section on, it's on page 536. If you look up latitude by meridian transit in the index, it'll take you there. Tons of stuff to read. Okay? But there's several formulas. Okay? There's formulas for contrary, all right? There's formulas for same, and there's formulas for lower transit. So how many of you guys, so there's three formulas that you're going to need to be able to use. Two of them are for when you and the body are on the same side of the equator, and then there's only one when you're on opposite sides of the equator. So have you guys been deriving those formulas? Did you have them memorized? Remember this, like latitude equals ZD minus dec. You remember that? All right, so you can figure that out. Okay, I'm not going to spend a lot of time on this, but let's say you're in the northern hemisphere and the body is in the south. Okay, let's say sun. You're contrary. Okay, and the formula here is going to be, this is latitude. That's what you want. This is declination. Yeah, and then this is going to be ZD. That's the arc from your zenith to the body in space. And so you can say, well, if I want this one, I got to take this one and subtract that one. So for contrary, it's latitude equals ZD minus dec. Okay, so you can derive it. But I'm going to show you where you can just pluck these formulas right out of Bowditch 2. And Bowditch 2 is what you're going to have in the exam room. Okay? If you want to, at the end, if you want to go through and derive formulas, I'll be happy to do it. There's a whole bunch of ways of doing that, but I'm going to take you to a diagram about it. So we're going to skip right over this slide. Okay, so what is meridian transit? I already told you. It's when a body's on your meridian, okay? And at that point, it bears, if it's north of you, it'll bear north. If it's south of you, it'll bear south. It could be right above you at your zenith, okay? When a body is on your meridian, the line of position ends up being exactly east-west. So it's parallel to a parallel, which makes it a parallel, which makes it latitude, okay? So whenever a body is on your meridian, you can get your latitude very easily, okay? It's a big deal. And you can use any celestial body, but when we do the sun, since we use the sun for time, we call it local apparent noon. You can do it off the moon, you can do it off of Mars, you're not gonna call it local apparent noon, you're gonna call it meridian transit. Okay, so what is needed? You need the declination of the body. You're just going to look it up. Okay, you know how to do that. You need ZD. Okay, you need ZD. Okay, and the definition of ZD is zenith distance. Okay, that's not zone description now. It's zenith distance. Okay, zenith distance. Okay, and zenith distance is really it's really an angle. Okay, so I'm standing here, I'm at 42 degrees north. I'm pointing at 40 or 44, whatever the frick we are. I'm pointing at a spot in space that is like 44 degrees north. Okay, and north is actually the Polaris I know is about right over here. It's over the golf course. Okay, so I'm pointing to the golf course right now. So actually, this is south. So if this was noon, it was daytime. This is my zenith. The sun would be on my meridian. It would be due south of me, okay? And if I could measure the angle in space from my zenith to there, I mean, how many degrees is that? 40. I can combine that 40. I can tweak it a little bit, and then I can combine it with the declination, and out pops my latitude. Wicked simple, okay? All right? So, but how am I going to get this? Well, I'm actually going to get that, okay? I want zenith distance, but when we're out there with the sextant, are you pointing the freaking sextant at the top right up there? No. You're pointing it at the horizon, okay? We take this angle, HO, and we subtract it from 90, and that gives us zenith distance. And the reason is because out on the boat, you don't know where your zenith is, okay? So you got to use something that's stable, and that's the horizon. So we use HO as a proxy for ZD, okay? So get ZD, 90 minus HO, okay? Every one of these formulas is going to involve ZD and declination. So every time you're going to have to take HO and subtract it from 90. And then you'll add declination. You'll subtract declination, or you'll subtract this from declination, okay? But every one of these is going to involve 90, HO, and something that you're going to do with declination to the ZD afterwards, and you're done. Okay? All right, so this is the page in Bowden. It's actually 2 pages. It's page 538 and 539. All right? Did you guys see now? Did you draw diagrams kind of like this? Okay? I'm going to show you exactly how this page is organized. Okay? All right, so if you're at home, you kids at home, pull your books out now, get your pencil out, okay? So I'm going to show you exactly what formula is what in what condition, okay? And we're going to need to decipher these pictures just a little bit, okay? But here's how it works. There are 538 and 539, okay? Bookmark these pages. There are several formulas here, okay? Can you guys see the cursor on the screen? Okay, see this right here?
Really?
Yeah, okay. All right, so here is the, I don't know, maybe I can change the color of the cursor, make it hot pink or something. Anyway, this is a formula for latitude. L is Z, Z is zenith distance, and D is declination. So latitude in this situation, if you're this situation, latitude is going to equal zenith distance, which is 90 minus HO, plus declination. Now you come over here, this on the other side, this is latitude is declination minus ZD. Okay? Guess what? These are the formulas for SAME. Okay? So if you and the body are on the same side of the equator, you're going to use one of these two formulas. I'm going to show you how to choose the one in just a second. Okay? But the first question you're going to ask yourself when you go to this page, you're going to ask yourself, I think it's two questions you're going to ask. Okay? Question one, am I same or contrary? Okay, am I same or contrary? If you're same, okay, same, there's two formulas. At the top, okay? If you're contrary, there's one formula. Okay? So, turns out that the top two, the one on page 538 and the other one on page 539, those are both for same. Okay? There's two situations for same. We're going to dive into it in just a second. Okay? So it's same and same. We'll add another note in that in just a second. If you drop down, this next one down there, that's contrary. Okay? So the middle one on page 538, that's contrary. So there's only one formula for contrary. But look, they give it to you twice. Okay? All right, one of them is where you're in the north, the body's in the south. The only difference between the two middle diagrams is, in one of them, you're in the northern hemisphere, the body's in the south. In the other one, the body's in the northern hemisphere and you're in the south. It's the same formula though. So if you're contrary, just go and grab the formula. Only one formula, okay? Now, down at the bottom, you see that bottom one on the left? That's same as well. But what's the formula? L equals Z plus D. You see that? Well, look, that's the very first freaking formula. L equals Z plus D. And this is just showing you, oh, you could be same, but you could be both in the southern hemisphere. You can both be in the northern hemisphere. So you can ignore that one, okay? You see that very last one? That very last one? That's for observing the body over the pole. Okay, that's a lower transit. That's when the sun, that's where you're far enough north or you're far enough south that the body doesn't set. Okay, and so you actually have two meridian passages in the day. One when it's on your meridian and one when it's 180 degrees around from you. That's the formula you use on that. Okay, I don't think the Coast Guard's going to ask you that question, but that's the formula you would use. All right, let's dive into this just a little bit more. Those are both same. Those are both contrary, but the contrary is the same formula. Okay, so there's really only one formula. So what I would do is I would just X out the, if I was you guys, I would just, I would circle this formula, I would circle this formula, and I would circle this formula. And I would label this S, S, and this C, and then we'll add one more thing, okay? Now you gotta look at this a little bit carefully. I'm just gonna reproduce this picture and then we're gonna get into it. It's worth me doing this with you guys because once you get how this is organized, you just go and you pull the formula out. You can never make a mistake. So in this guy right here, okay, so this is supposed to be like your meridian. It's like you cut the earth in half, okay? And here, the way this works is your zenith is always at the top. So this is the horizon. This is the horizon, okay? Now, you see this here? M. So zenith is U. That's the spot above you. M is the body. Meridian transit. Okay? And then there's one other letter we're really interested in. That's Q. Equator. Okay? So, here's the equator. Oh, and over here it's like it's pole, it's a north pole. Could be the south pole, I don't really care. This is what's important. Here's the equator. Is the equator between me and the body? Then we're same. Okay? We're on the same side of the equator. This is same. Okay? I'm going to draw the other. I'm going to draw the other one. Okay? So Z is always at the top because it's always above me. Okay? And now I'm going to put Q here, and I'm going to put M here. Is Q between us? Then we're same. We're on the same side of the equator. What is different about these two situations? What's different? Who's closer to the equator here? Oh, the sun, the body is closer to the equator. Who's closer to the equator here? You. Oh, that's why there's two different formulas. Okay? So, this formula right here is same, body closer to Q. This is same, body closer to Q. And if that's the case, the formula is L equals Z plus D. And that's really to say lat equals ZD plus dec. Okay? So, your latitude is like you're around 40 north and the body's around 20 north. Same? Who's closer? You? Body. Who's closer to the equator? The body. Okay, so I look for same, the top two, and I look for the one where the body's closer. Boom, there's the formula, done. Don't even have to derive it. What's this one? This is same, U closer to Q. Oh, well, that freaking formula is L equals D minus Z. And that's lat equals dec minus ZD. Done. So, in this case, if we flip this, so your 40 north is the body, and 20 north is you. Well, this is saying you're closer. You use this formula. Okay, so what I would do is right on the sheet, right on page 558 and 559 or whatever it is, right here I'd write same, body closer to the equator. Over here I'd write same, me closer to the equator. And down here I would just write contrary. And down here I'd write over the pole. And over here I'd write ignore this one. Okay, because this is just a repeat of that. Okay, so same, body closer to the equator. Same, you closer to the equator. Contrary, ignore, over the pole. And then when you're looking at your latitude and the body's declination, you can just say, oh, we're same, I'm closer. We're same, they're closer. Go pluck your formula out. Okay? So I think that was worth maybe the 5 or 10 minutes we covered on that. Okay? So these are the two questions. One, are you same or contrary? And then if you're same, who's closer to the equator? That's all you need to know. You can pluck out your formula. Okay, two questions. Maybe you write those questions at the top of the page. One, are you same or contrary? Two, if same, who's closer to the equator? Choose your formula. All right? Cool. All right, and anyway, I don't need to do this because I blew it up on the board. Okay, so now we're going to do problem 5. Any questions about that? Okay. All right, we're going to do problem 5 now. And then we'll come back and we'll do problem 1. All right? So problem 5 on your worksheet, this is it. It's November 7th, 1981, and your 8:30 zone time gives you a position of latitude 27, 36 north. Hey, What's your latitude here? North. It's November. It's winter. Where's the sun? What hemisphere is the sun? So what's the formula going to be? You're in the north, body's in the south. It's contrary. How many formulas are there for contrary? One. So you already know what the formula is. One of those middle best. What's the formula? Z equals mu minus D. So I already know what the freaking formula is. I haven't even started the freaking problem. Okay, but for this one, lat's going to be Z minus D. So that's 90 minus HO minus declination. So now I need HO. I need declination. I think you can do that. Okay. Oh, and then just run it through the, plug and chug. Yeah. Okay. So here we go. This is worksheet 7, problem 5. So I'm going to plug some data out of here. Date, body, usual, lat, longitude, zone time. Now I got to calculate declination, so I need GMT. I need the date. I need GMT. Okay. GMT. For a lot of these, they don't give you the chronometer, so you don't have to do that double time thing. You just can do one time. Salute. Okay. And then once I have that, well, then I'm going to need to find my deck. I'll need my D factor, plus or minus. I'll get my deck. Okay? Cool? Now, you might have to go HS to HO, or they might give you HO. In this problem, they're very nice. They actually gave us HO. There's no HS to HO. Okay? Very nice. Okay? So let's pluck a little data out of here. It's 7 November. The body is the sun. We shot the lower limb. Our latitude is about 2736. You're like, hey, you know what? If my latitude is 2736, why am I doing this? Because this is your DR latitude. It's an approximate latitude. We want to nail this bastard down. Okay? So our approximate longitude is 162.19 west. Okay? At 11:38, we make an observation of the sun. At 11:38, our DR is here. We're probably within 5, 10, 15, 20, no more than 30 miles away from it. Okay, depending on when our last fix was. Okay? But if we had a good fix this morning for stars, we're going to be within 4 or 5 miles of this. If we haven't had a fix for 2 days, we might be 30 to 60 miles away from it. Okay? But anyway, so it's 11:38 local time. You know it's 11:38 because that's when you were out there with your freaking sextant. So now, to get declination, I need to convert that to GMT. Okay? It's 11:38 local time. You're like, oh, the sun's going up. So, oh, it's hanging. It's hanging. It's hanging. Oh, it's starting to go down now. Oh, 11:38 was about the time it was hanging. So, zone description for 162 is plus 11. Okay? So that makes it GMT 2238. Okay? 2238. All right? So now you got to go to 7 November. Do I even have that? Okay, so we got to calculate the declination of the body. We're going to do that. We need our HO. Got to subtract it from 90. Choose the formula. We already know what the formula is. Okay? So, okay, I didn't actually go to November 7th. I don't have a picture of it, but here we go. What page is November 7th? 217? Okay. So I go to 217, I go to November 7th, I go to 2200, okay, and it looks like the declination of the sun is at 2200 is south 1627.4. So this is south 1627.4. Is that right? Okay. What's the D factor for the sun? Okay, so I drop down here. The D factor is 0.7. Is it plus or minus? Plus. So it's plus 0.7. Okay, so this is 36 minutes, so it's going to be a little bit more than half of 0.7, so I think it's going to be 0.4. Okay? Anyway, you can do it in your head if you know how to do it in your head, but otherwise, we got to go to 38 minutes. and get the D factor for 38 minutes. It's 0.4. Okay, so I go to the back of the book, 38. There's 38 minutes. Here's the D. 0.7 is 0.4. So we add 0.4. Okay? So that's south 16, 27.8. Okay? Cool. Great. Now, I'm just going to draw a little picture here. Q. Okay? Now, I spent a lot of time on tall ships, so I like to just go like this. Okay? That's me on a square rigger. Okay? So I always put that symbol. Anyway, so this is U. And this is body. So that's contrary. So now we go to page 538, 537, and 538 in the book. Okay, now we go to Bowditch. So go back to that page. We're contrary. What's the formula again? L equals Z minus D. Okay? Okay, and they also gave us an HO in the problem. Okay, so remember that ZD is 90 minus HO. So ZD in the problem, or HO in the problem, what did they give us? 45, 35? Okay. I got to subtract that from 90. So, ready? Here's how I'm going to do that. How are you guys going to do that? I'm going to do this, 90. Okay, but I know I'm going to have to be subtracting some little bullshit here, okay? So I'm going to go, 90 is really 89, 60, isn't it? Okay, and another way of saying this is also 89, 59, and 10 tenths. Okay, see if this was like 35.3, if this was 35.3, I'd use 89, 59, and 10 tenths. Because I could just take the 3 away from the 10 tenths to be 7, okay? But in this case, I don't need 89, 59, 10. I can just use 89, 60. 89, 60 is really 90, because 60 of these makes one of those. So I'm just getting it ready to do a little bit of math. So now I'm going to go 45, 35, subtract. So that's not too bad. That becomes 5, that becomes 10, that's 5, that becomes 2, that becomes 4. 44, 25, is that right? Okay, that's ZD. Okay, that's ZD. Cool. So now I'm doing this. So I'm going to subtract the deck. What's my deck? 16. 27.8. Okay. Now I got to subtract that. Well, all right. Well, this is less than that, so I got to borrow. So that becomes 43. When I take 1 from here, how many of these does it make? 1 from here is how many of these? 60. So what does 25 become? 85. 25 plus 60 is 85. So this becomes 85. So 27.8 from 85. Now you can use your calculator. What's that? Okay. Yeah, that is 57.2. And what's it over here? 2757.2. That's what? That's our latitude, right? That wasn't too bad, was it? Okay, so what answer is it on your answer key? What's our latitude? It's B, right? Yeah? What's the answer to the question they asked us? Why is the answer not B? So I just want to point something out to you. Look, we put these worksheets together to show you the tricky shit that you're going to face. Your latitude at 1138 at the moment of LAN was definitely 2757.2. That's answer B. But that is not the freaking question you were asked. Go back and read the question. I'm gonna give you a second to read the question. Oh. What do they want? They want your latitude when? At 11:38? They want your latitude at noon. So what are you gonna have to do? Now you gotta advance. Okay, you gotta be careful because you did everything right, but you didn't answer the right question. And why do we give a crap about noon? It's for the noon report. Okay, it's for the noon report. For how many miles we made from noon yesterday to noon today. So we can let the charterer know. So in fact, you have to actually advance this now. Okay? So you can do that a couple ways, but now you can draw a picture. Okay? We're at 2757.2 north, and we're west, so we're over here. Okay, so I'm just going to draw like a little dot there. In what direction are we going? 289. So 289 is like that. So we're going to go for 22 minutes at 289. Are we going to go more north or more south? More north. Can we eliminate any answers? Any answer that is less than 2757.2, we can eliminate. So yeah, we can eliminate A because that's less than 27. And we can eliminate B because that is our freaking latitude at 11. We got to be more north. So it's one of those other two. There's not a big difference between the two of them. So how are you going to resolve that? It's not going to be A, it's not going to be B. But, so you're either going to be 2.3 miles further north, or you're going to be 4 miles further north. So there's only two ways you can answer this. There's only one way you can answer it for sure, and that's to advance and see what your new latitude is. So you can get out a plotting sheet and you can actually advance and then see what the new latitude is. Okay? Or you can also say, you know what? I'm going for 22 minutes. 22 minutes. How fast am I going? What's my speed? Okay, so 22 minutes, that's 38 to noon. Okay, so noon, 11:38. That's 22 minutes times 19 knots. That's 7 nautical miles. That's as far as I'm going to go in 22 minutes. What direction am I going? 289. Is that mostly west or mostly north? So of that 7 miles, most of it's going to be, so literally I'm going to go like 7 miles like that. Okay? So how much do you think my latitude is really going to change? Not much. I'm betting you it's going to be C. Okay? But the only way to really know is to do an advance, and you can just do that on a plotting sheet or whatever. Okay? Yes.
So could you just solve it out, not without advancing it, and you know that if you get the exact answer in speed?
Well, how would you solve it out?
Like what you did when you did it.
I didn't solve it out.
No, I'm saying if you just did the problem without advancing it, and you got an answer that's on there, you can cross that answer out, right? If they're asking you for an advance.
On the Coast Guard, they're not going to look. Okay? I'm going to look though. So you have to justify to me that you understand that you had to advance.
Yeah.
Okay?
So the only way to get like the exact answer, you actually plot it on a sheet, like advance on your D.
No, you can do it by sailing. You can do it by plane sailing and calculate your D-lat. There's a formula for D-lat. So that's what I would do. But we're not covering the sailings until the next test. But I would use if I really wanted to do it, I would just bang out the D-lat formula and it would give me 2.2. I think if you do the D-lat formula, it's 2.2 miles, 2.2 minutes, and that makes it C.
So on the test, if we drew up something like what you have on the board behind you, that would give us credit for showing that we know to advance?
You have to be able, you can easily eliminate A and B.
Yeah.
So I'm not sure if you can, I guess, how would you let me know that you knew it was only 2 miles instead of 6 miles? Well, here's how. It's 7 miles. The whole distance is only 7 miles, and it's mostly west. There ain't no way I'm gonna go almost 6 miles. So it's gotta be the 2 miles, okay? So that's a way you could reason out the Coast Guard answer. But if you were making a report for your company, you would have to advance.
Show them.
Yes, because they want you, they want to know, okay? Yeah, they don't want guesswork, okay?
Captain Tarrant,
Yeah.
so do you want us to have plotting sheets and figure it out, or is that good
Dude,
enough?
you're gonna have plotting sheets, because on this test, you're gonna be plotting LAN, you're gonna be plotting sun lines, you're gonna have plotting sheets already, okay? And I do not
10-4.
recommend that you use the universal plotting sheet. I recommend that you go down to the store and you buy 923 and 924. Okay, they're $2.50, maybe they're $3 this year, okay? All right, let me go grab one.
You're not going completely parallel, so it's gonna counteract what it is, so 7 miles, 7 true miles of latitude. It's gonna be doing, I don't want to, you're gonna cover less distance horizontally than you would vertically.
So here's the universal plotting sheet, okay? You have to set this up. It takes you time to set this up. You could set it up wrong. Then when you're doing longitude, you got to deal with this freaking logarithmic scale. You can make mistakes. It's a pain in the ass. You can make mistakes setting it up. You're going to use time setting it up. You can make mistakes using it. But then there's this. You can buy this for $2.50. It's about the same size. Okay, this is not yours, but it's 923 and 924. It's already set up. You can't make any mistake. And it's got the latitude scale and longitude scale. You can just read right with your dividers. No mistakes. Okay? I recommend you use this. And not only that, but look how big a latitude, this is a degree of latitude. It's almost 2 of these. Okay, a degree of latitude on this is this distance, which is almost 2 degrees of latitude here. Which means when you make a little error with your triangle and you're a millimeter off, that's a mile on this scale. It's half a mile on this scale. And the tolerance on some of the answers with the Coast Guard is 1 mile. So if you make a little with your triangle, you're a mile off. You get the wrong answer. If you make a little with your triangle on this one, you're a half mile off. You might still get the right answer. Saves time, no mistakes.
What are those chart numbers?
The 923 and 924. Okay, it's in your syllabus, and they have them down at the bookstore. They're waiting for you guys to come by them. Okay?
Are we allowed to use the VLAT formula to do that?
Yeah, if you know how to do it, dude, you can do midlat if you want. Okay? So I would just use plain sailing, but you can use midlat. You can use you want to do great circle sailing for the advanced? Go for it, dude. Okay? I'm just not going to show you how to do that until the next unit.
So, but if we solve the whole problem out without advancing it, and then we show it to you that we know the tolerance is only 7 nautical miles.
Well, then if you said to me from 11:38, if you said to me from 11:38 to noon, I would only, at this speed, I only go 7 miles. I'm going mostly west. So I would only go a couple of miles north. If you wrote out a little statement like that, I would accept that. Okay? All right? Okay? Because I know I'm going to catch you on the advanced part somewhere else on the test.
If they ask you to advance like that, what are the chances that they're gonna put one of the answer?
Oh, they will always put the answer for 11:38. They will always, listen, they always put the most common mistake answer in there. Okay, that's how they roll. Okay, that's how they roll. Okay, any questions about that? So Hart, did that answer your question? Hart,
Yes.
did I answer your question?
Yes.
Okay, cool. All right, So, now, that one's done. Now, there's another part to tonight's worksheet, and that is pre-computing the time of LEN, okay? So now we're gonna do problem 1. All right? And I'm gonna do two different ways. Well, actually, I'm only gonna do it one way. Okay, you guys learned in, you guys got these instructions somewhere. I think it's probably CNAP. Does this look familiar to you? Is this a handout that you got? Does this look familiar to you at all? You didn't get this? You didn't get that? To determine time of local apparent noon by GHA method? To determine the time of local by the almanac method? That doesn't look familiar to you at all? Okay, well, screw it then. Okay. All right, so there's 2 different ways of doing this. One is the GHA method, okay? And if you had Captain Chase for CNAV, although I don't know when the last time he taught it was, that's the way he taught you. But Jurgensen and Miller are going to teach you the almanac method. So I'm going to go over the almanac method, okay? I think it's easier than the GHA method, but they both work, okay? You say, you start talking to Captain Chase about the almanac method, he's like, what the hell are you doing that for? Just do the GHA method, it's really easy, okay? So, sometimes you want to be able to predict what time LAN is so that you can set an alarm to go out there like a couple minutes early. So that you can, because you got tons of other crap you got to do on watch. Right? You don't want to miss LAN. Although if you do miss LAN, you can shoot LAN early or late using Experty in transit. You're going to have to do that on your chief mate license. But anyway, let's not worry about that right now. I mean, if you're a VOT, you'll have to do it for your master. Okay. Anyway, so it's 31 January, and it's 9:20 in the morning. So it's 9:20 in the morning, and we're trying to get an idea of when LAN is going to happen in the future. So what that means is that there's going to be a little bit of advancing involved here, okay? So I'm going to put the instructions, bulleted instructions over here. 1, okay? Look up time of MP. MP stands for meridian passage, okay? And if you don't remember where that is, I'm going to show you and you'll be like, oh yeah, I remember that now. Number 2, advance to time of meridian passage. Okay? Number 2, advance to the time of meridian passage. These are the instructions for the almanac method. Okay? So you got to look up the time of meridian passage, then you advance to the time of meridian passage. Step 3. Hey, this is going to sound familiar. Convert longitude from arc to time. Hey, we did that last class. Okay? You were left with a few questions about that. I'm going to solve those questions tonight. And then step 4 is apply the time from step 3 to step 1, which is always going to be add, you know. It's morning, LAN's going to happen a couple hours later. You're going to add the time, okay? It's, you got it. You're never going to subtract this time because who gives a rat's ass? When did LAN happen? Well, 3 hours ago. Well, who gives a crap? We missed it, okay? You'll always add the time from step 3 to the time of step 1. So that's what we're going to do now, okay? So, okay, so the instructions that I just wrote here on the board, are these instructions, okay? It's slightly different words, but it's the same instructions. This is 3 steps. I think I just kind of combined 2 of them over here, okay? We call that the almanac method, short form. Those are the instructions for the GHA method, okay? So let's just try this one first, and if anybody wants to review the GHA method, I'll show you after, okay? All right, so so step one, look up meridian passage. Where do you find meridian passage? Yeah, it's on the bottom. It's on the bottom of, you go to your daily page and it's at this bottom right-hand corner. Okay, so we're gonna need that. But before we do that though, let's pull some data out of here that we're gonna need, okay? So this is worksheet 7, problem 1. I need to know the date. I wanna know the body. Of course, I want my lat. I want my longitude. I need my zone time, okay? I need to know what time I'm starting, okay? Because I'm gonna need it for my advance. I need my course. I need my speed, okay? And I'm gonna need meridian passage, okay? So, what's today's date? 31 January, okay, great. That's good, I'll need that. Well, I don't really need that, but anyway. I need that because I need to go into my nautical almanac and look up MERPAS. Okay, what's the body? Oh, it's the sun. Okay, great. That's good because now I know which column to use. My latitude, my approximate latitude at 9:20 is 2416 south. My longitude is 151.33 east. Okay, east, so we're gonna have some fun with that one. Okay. My zone time is 0920. My course is 258. My speed is 18.5. Okay? All right. Cool. So, I'll give it a second. So this is the data I'm going to need. I'm going to look this up in just a second. Okay? But I need these numbers to do what I'm going to do. All right? Cool. So step 1, look up the time of MERPAS. So here we are. We go to January 31st, and down here in the lower right-hand corner is this box. And it says day 31st, 1st, 2nd, MERPAS 1214. So 1214. Okay? We're done with step 1. Okay? Step 1 is done. Now, step 2. We got to advance to MERPAS, which is 1214. Okay? We got to advance. All right? So, let's do that. 1214, I started at 0920. All right? So that turns out to be 2 hours and 54 minutes. Okay? I'm going 258 at 18.5 knots for 2 hours and 54 minutes. All right? So that is times 18.5 equals 53.7 nautical miles. Okay? All right, so in 2 hours and 54 minutes, I'm going to go 53.7 nautical miles on a course of 258. Hey, 258. What's that? That's mostly west, isn't it? So what are my options now? I can actually plot it on the plotting sheet, or since we're going mostly west, I can do the down and dirty. Okay, I can do the down and dirty. So let me figure out what I'm doing. I'm going to draw a little. I still need a picture. Okay, so for my pictures, I just do. That's the prime meridian. That's the equator. I want to figure out which quadrant I'm in. Okay, prime meridian, equator. I'm 24 south, so I'm down here somewhere, and I'm 151 east, so I'm here. So I don't really care where I put my dot in that box. I just need a dot in that box. I usually put it about in the middle. Irregardless, 151 should be farther over here, and 20 should be up here a little bit more. but I'm just getting an idea, okay? Now, I'm going 258. So, am I gonna be going east or west? I'm gonna be going west. And am I gonna be going a little bit north or a little bit south? Well, 258 is, yeah, it's west and a little bit south. So I'm gonna be doing this. Why do I need that arrow? Because it's gonna tell me how I'm gonna apply this for my down and dirty. Okay? So, this is at 0920. I'm at 151.33. I'm going west. What's going to be happening to my longitude as I'm going west? Okay, so I need, if I'm doing the down and dirty, I'm going to subtract it. So what I'm going to do now is the down and dirty advance. D and D advance. Okay, at 0920, I've got 151.33. Since I'm going mostly west, I'm just going to apply this whole thing as if it was all my change in longitude. And you know what? I'm just going to make it 54. I mean, I'm going to make it, it's 53.7. I don't really give a rat's patootie about the 0.3. I'm just going to make it 54. Are you all okay with that? Okay. If you're not okay with this, you got to bust out the plotting sheet. You got to plot this thing, and then you got to do the 54 miles. But if you can wrap your brain around this down and dirty, which is what I do in the real world, okay, then I'm going to subtract 54. Okay? I'm going to subtract 54 minutes. Now, that's going to be excess. It's more than I went, but anyway, it's going to be fine. So when I do that, what do I get? Okay, 150.39. Now, if I had in fact done this by sailings, just if you're interested, if I had done it by sailings, it would have been, what would it have been? 150.35.4. It would have been 35.4. That's 4 minutes of arc. And we looked in the book last time, that was 20 seconds a time. So it doesn't matter. Okay? So, we've done step 1. We've done step 2. Now we got to do step 3. Okay? Arc to time. Okay? And then we apply it. Okay? So, let's do this. Let's do this the way that's familiar to you. Okay? You ready? Okay, I'm gonna go in here. Let's do this. Okay? 150 east. And where are we gonna be? We're gonna be 150.39. Okay? So my central meridian is 150. Okay? And what time was that? That was 12:14 was when the sun is going to be on 12:14 is the time for LEN at 150. But I am 39 minutes to the east. So what does that mean? Well, it's not rising. Okay, rising, this is the sun actually coming onto your meridian. So it's going to be there to the tune of 39 minutes of arc earlier. Okay? So here's what I do now. I got 12:14 local time. Now I have to do 39 minutes of arc. Okay, so I look in the book. What's 39 minutes of arc in the book? Okay, so yeah, if you go to arc time, okay, the very first yellow page, 39. So 236. I don't really care about. What are you gonna do? You're gonna make it 2. You're gonna make it 3. What are you gonna make it? 3. Okay. So that means we're gonna subtract 3. And what does that give us? 12:11. That's the time of LAN, 12:11. Okay? We're done. All right? We're done. Now, for those of you that are interested, I'm going to show you how to do this the other way. Okay? If you're interested. If you're happy going off your central meridian, then you're done. Okay? If I was in west longitude, I would do it off of Greenwich. In fact, I think I would do it off Greenwich all the time. And I'm going to show you how to do it now. It's all right. So if you're satisfied, don't listen to me for the next 5 minutes. But if you're curious, okay, I got jammed up. I got a little brain kerfuffle last class, and I've unkerfuffled myself. Okay, so I'm going to show you how to do it another way, which is always add, but not quite as easy in the East. All right. Okay, here we go. So if you're satisfied, just go off and work on the worksheet now. Okay, if you don't want your brain, your eggs scrambled, don't listen to me. All right. Okay. So we just figured that the sun should be at 150:39 east. By the way, where will we be? At 150:39 east as well, at LAN. We'll both be at the same meridian. We'll both be 150:39 east, okay? So now, this is what you need to do, okay? To do the wicked easy, always add not quite so easy in the east. What you need to do is you need to convert longitude to GHA. You need to convert longitude to GHA. Okay? Now, when you're in the Western Hemisphere, longitude equals GHA. It's only when you get past 180 that you have to do a transformation. So when convert longitude to GHA, so when you're east, subtract longitude from 360. Okay? So I got to subtract 150:39 from 360. So that's 359.60 minus 150:39. Okay? So what is that? That's like 11 or something like that. Yeah, that's 21, 209, 209.21. Okay? So if you were looking at this like a polar diagram, okay, if you were looking at this kind of like a polar diagram, here's 0, and there's 180, and this is west, and this is east. So we went all the way around to 180, and then we went another almost 39 degrees, okay? So this is where we're at right now. This is 209.21, which is GHA of 150:39. Okay? So now, well, I got 12:14. So now I'm going to do 209 degrees and 21 minutes. So what's 209 degrees? $13 hours and 56 seconds?
Yep.
And 21 minutes? It's like 1 minute and change. Right? So that's going to be 1. So now I add them all up, and I will always add them up. Okay? The only subtraction I did in this method, the only time you're ever going to subtract, well, there's going to be 2 times. But anyway, I have to subtract here to get GHA. Now I'm going to add all this up. So that's 10, 11, 1, 5, 6, 7, 7. 3 and 2 is 5. 2571. 2571 GMT. I'm going to take 60 out of this. Okay? So I'm running out of board here. Let me do this over here. Okay? 1214 GMT. I'm going to add 209 and 21. That works out to be 13, 56, and 1. That ends up being 2571, which becomes 2611. Okay? Now, I'm going around west, which means my zone description is actually plus. So now I got to figure out, now the last step I got, there's 2 more steps. What I need to do now is I need to divide 209.21 by 15 to figure out how many time zones it is. Okay? So to figure out my zone description, I'm going to take 209.21 and I'm going to divide it by 15. So that becomes 209.33 basically divided by 15, which when I do that turns out to be 13.9. So that means my zone description is plus 14. So now I subtract 14 and I get 1211. Same time. All right. So that's not for the faint of heart. Okay. All right. That's a little harder in east. Okay. But that's the way to do it. Otherwise, if you're comfortable going off your central meridian, you might just, okay. Anyway, it's up to you.